xy over delta x. How does it expand? Do you guys remember?
Y2 minus Y1.
Yep, over. Yep, so that's really our formula for slope, right? The difference in y's over the difference in x's. So another word that we can use to, we said this is delta. Do you guys know the other word I use? Like, instead of the difference in y or the difference in x, we can use the change. You heard that? The change in y? Change in y over the change in x. Okay? That's another thing that we can do. Oh, I kind of gave that away. Mathematical concept that it represents is slope, okay? And then what's another phrase that you might see that represents that? Do you know? Oh, can I start you off? The average. Average, it's something we learned about on Friday. Yes, sort of, yep. Rate, average rate of change. Average rate of change, we got there. So that's kind of what I was looking for. So the average rate of change, that's something you might also see. So rate of change.
Stop.
All right. So today, first of all, did you guys have any questions on the worksheet from Friday, like perpendicular lines? Did you figure out how to do the calculator, like stuff?
Yeah, at the end, we talked about it.
Good, okay. Yeah. I also downloaded an actual 84 calculator. I had a free thing, I found it. Anyway, I spent 2 hours with Apple support on the phone on my Saturday. I was so mad. They locked my personal Apple ID. Like, I couldn't open it again. I mean, it was awful. So it was a mess. It was a hot mess.
That's what my mom used to do when this guy stole an iPad off of our front porch. And her mom.
Oh my
She
gosh.
was all about it, and it was so heavy.
That's awful. All right. Okay. So, do you guys know what this mathematical concept is? Sometimes I go off on a tangent. All right, this is a tangent line. Hilarious. So this is a tangent line, and this is a secant line. A secant line goes through 2 points on any line or curve. So we're going to talk about, the goal in calculus is to find the slope of a curve, which tangent lines allow us to do. So we're going to do like the basic algebra part of it today. Secant line is the slope of a secant line is between 2 distinct points on the function. And it's obviously your slope formula, but another way we can write this is, so this is in your packet, P4 lesson 2 notes. So another way we can write this is f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. So do you guys recognize that this is saying the same thing, right? F of x is the same thing as y. So this is just saying when you plug x sub 2 into this guy and x sub 1 into this one, you get your corresponding y values, y2 and y1. Okay? So just know that. We write things a little bit weird in calculus here. Now, a visual for this, I do want to draw a nice little visual for you. If we draw like a, I'm going to zoom in here. Okay, if you have, let's say this is x sub 1 and this is x sub 2, okay? And you have some kind of curve like this. And you have 2 points at x sub 1 and x sub 2. And if you draw a line going through those 2 points, that is a secant line, okay? A little bit. So this is the secant line. Okay? The tangent is different in that it's only a line at 1 point on, so it's, the slope of the tangent line is at 1 point on a function. And what you do is you find the slope and use point slope form to write the equation of the tangent line. A visual of this will be, make your xy. So let's say we have the same, oops, sorry, that's supposed to be a 1. x sub 1, and x sub 2. So let's say we have the same kind of a curve, just like that. Okay. Instead of 2 points, right, those would be our secant line, we're just going to take at 1 point, this would be an example of a tangent line. Okay? Now, in calculus, I'm going to teach you how, as we get, this, if we get this secant point, you see this black point here, if I bring it closer and then I get the secant line, and I get it closer and closer, I get the secant line, as x sub 2 approaches x sub 1, or as it gets closer to x sub 1, we end up with our tangent line. You see how that's going to eventually work? So we'll eventually, we're saving that for another lesson, but that's where this is going to go. For now, let's just practice writing equations of these. So if I give you a line tangent to f of x, so this is f of x in blue, at x equals 1. So I basically just want you to write the equation of that line. So what two things do we need here? We need, well, we have this coordinate, right? That's helpful. So that's the coordinate 1, -1. So it's at 1, -1. And we also need what? The slope, right? We need our rate of change. So the slope here is, now because it's a visual, this is really the only context right now that you can do that. You're just gonna find your slope. You rise over run. So I go from this point, I go up 2, right? And then up 2 and over 1, right? So it's going to be +2 and -1, right? Okay? Or if you went down to -2 and then over +1, so either way. Okay? So, we're going to say our slope is -2. And then we're going to write the equation of our line. So we have, do you guys remember, oh, actually I have it there, but let me cover it up. Let's see if you remember it. Point slope form, it's everywhere. Y minus, what? Y sub 1 is equal to M? Yes, okay? And we get that from, I think I told you, if you have the slope formula, you just multiply the x2 minus x1 over. That's how you get point slope. Okay, so let's plug it in. Y minus, this is y sub 1. So minus -1 is equal to -2 times x minus 1. So we should have y plus 1 is equal to, distribute your -2, -2x plus 2, subtract 1, you get -2x plus 1. Okay. This would be slope intercept. If it just says, I think actually I didn't read the directions. It wants it in point slope form. So actually you could have stopped. You actually could have done this. So point slope form, you can do y plus 1 is equal to -2 times x minus 1. That's like in point slope form. Okay? Sorry about that. Should have read. Okay, you want to try the your turn problem? I think that'll be good. Go ahead and give that a shot. Okay, so you should get, this is at the point -2, 2. So that's my point. It's going through that point. My slope is +1, right? You go up 1, right 1, and you get to your next point. So my slope is just +1. So plugging into this formula here, y minus, this is y sub 1, 2, is equal to 1 times x minus a -2. We're going to simplify that double negative. That's all you need to do. And then 1 times x plus 2. You don't really need the 1 there, you could just do that. Cool? Tangent lines, good? All right, the next bit is same stuff but in a different context. So it's saying, and this is the last example for today, really quick lesson, and then you can practice. Which choice represents the slope of the secant line shown? So I'm gonna let you just try that. So just look at it and see what answer you come up with. Take a minute, examine your choices, and see if you can figure out what represents the slope of your secant line in that graph. And if you need to look back at the formula that we wrote at the beginning, that might help. Nice. Oh, I'm seeing good answers. Okay, for those of you who selected a choice, you did really well. It is D, and let's talk about why, because I think there is still people, still trying to work to the answer. So remember, the slope of a secant line can be written as f of x sub 2 minus f of x sub 1 all over x2 minus x1. So your first point here, the x value is 2, right? And the second value is 7. So we know our denominator is going to be 7 minus 2, right? Just the x's. So that leaves out actually all of these, right? And then in the numerator, we take f of x, so it's f of 7, and f of 2. So it's f of 7 minus f of 2, and that would be your slope. Okay, does that make some sense? Okay, all right, so right now, this is another your turn problem. Go ahead to the assignment P4 worksheet 2, and the first problem on there is really similar to what we just did. So go ahead and start number 1 for me, and then work through the rest of that worksheet. There's some review on slope word problems that we did on the other day, and then parent function stuff. So it's a big old review. So that'll be good. And if you have questions, I'll be around, okay?